Okay, so I'm going to take you through some updates to SolidWorks plastics now. So on the screen here we have an iPhone with a case attached to it, and we'll just take a look here at a particular configuration that just has the moulded case in it. So we'll just reload that project up like so, and we'll go straight in and take a look at the first new improvement to SolidWorks plastics, which is the introduction of a getting started wizard. So very much like the rest of the simulation tools we have in SolidWorks, we can now run through a wizard-based system to set up our study. So if we just run through this here, firstly we'll choose a particular type of mesh to use, and it gives us a good description of the difference between the two. So if we start by using a shell mesh here, it'll open the property manager over on the left hand side for us. So firstly we would choose a domain, which is the particular body that we want to do the study on. And then we can specify a triangle size here, so the mesh size that we want to use, and then literally just click the mesh button and the system will do the rest for us. So the meshing in plastics is very quick, so you can see that mesh on the screen, and we just need to accept a couple of those boxes there like so. So once the mesh is created, we can then move on to the next step, which is to define a material for our study. So that's the plastic material we're using. So we can specify that we want to change the material from here, which gives us access to the database of materials that are available to us. This is a really comprehensive database with around 4,000 plastics within it. And it's really granular in that we could go into ABS as a material type and look at all the different suppliers of ABS materials with all the different grades that are available to us as well. So all the individual material properties come through for each of those materials, but you can also quite easily just use the generic material if you're not sure of the particular grade. So once we've specified our material, we can move on to the next stage, which is to have a look at the processing parameters that we're going to use. So if we use the change fill settings option here, what we can do is we can go into the processing options. So the first thing is we could choose to specify a filling time if we wanted to, or alternatively leave it with the automatic settings. The melt and mould temperature are picked up from the material that we defined, and the injection pressure limit is actually picked up from the machine that we're going to be using. We can change that within here, so we could go into the machine database and pick a particular manufacturer of machine and their type of machine, or alternatively just use the default machine that the system's using. So once we've specified those fill settings, we can move on to the next section, which is to apply an injection location to our component. So that is where the plastic is going to be injected into our part. So if we choose this option here, all we need to do is pick on the screen and it will place the injection location on there for us. We can specify a diameter for that as well. And if we click the green tick, we sort of have completed our setup through the wizard. So the next thing for us to do would be to run that simulation. We're not going to run that simulation, we'll just switch over to a completed configuration, just because it takes a little while for the simulation to run. So if we come into our completed simulation, we'll just take a look at some of the other options that we've got. So if we just read the results through into our system. So we've always had the ability to display a fill time plot, which will show how the plastic is moving through the cavity like so. But we've now seen a completely overhauled advisor section. So if we take a look at this advisor, it uses a traffic light system up the top, so green is good, it means the part can be moulded. But it will also give us a much more comprehensive description of why it can be moulded and any recommendations that the system can make. So we can see here that the part can successfully be filled with an injection pressure of 49 megapascals, which is about half the machine's limit. So the system is telling us we could reduce the part thickness if we wanted to and decrease the cooling time, but it's quite happy that our part can be filled with the options that we've specified. And these types of, this advice actually runs through each of the different plot types within the system as well. So it's really nice for helping us to learn what's actually occurring during moulding. One of the other areas we've seen improvement on is the Run a Design Wizard. So if we just switch back to another configuration here and start the runner design, we'll just shut that advisor down. We can start designing a runner system for our component. Historically, we would have had to produce a SolidWorks 3D sketch or alternatively some solid model to indicate the type of runner system that we want, but we now have a new runner wizard which will allow us to choose different types of gating systems, or alternatively we can choose different layouts as well. So I can now pick 3 locations for injection on this particular option, change some values here, so maybe make that 10, and we can create our own gate system very, very quickly. So that's really nice and a lot faster than it used to be. One of the other areas that we've seen improvement is the ability to export results. So again, if we just move to our completed project here, like so, within here we can now export results from the system. So we can export to Abacus, ANSYS or SolidWorks simulation. So we can export the in-mold residual stress to SolidWorks simulation. So let's take a look. So if we turn on simulation here, we've got a plot towards the bottom which is actually reading in those results. So in Nonlinear Analysis we can apply the residual in-mold stress as a load onto our component, and then that will run a study which will show us the residual stresses in the component, and also really useful is the displacement as well. So if you are looking at how your product deforms during cooling, we can now see that with the introduction of the new export options. Okay, so in summary, we've seen the new Getting Started wizard, the ability to use a runner design system wizard, the results advisor have seen a nice overhaul, and we can also calculate the effects of in-mold residual stress and export those to simulation for more accurate displacement results. So Alex is going to run us through some enterprise PDM improvements now.